You've heard a number of times, General Gaylor could not be with us here this morning, who is our aviation branch chief. I mean, he's the leader of the six-pack. But he did send in his place Colonel Ryan Cole, the TRADOC Capabilities Manager for Aviation Brigades, to bring his message, that'd be General Gaylor's message, that Colonel Cole is now going to provide for us. Hey, Dan.
Sir, thank you very much, and I appreciate that welcome. And General Gaylor does wish that he could be here, but there's just multiple competing events. So by no means will I be able to deliver as good of address as he would, but I will do my best in my role as the TRADOC Capability Manager to definitely represent, to serve as the user representative and represent all those soldiers out there in Army aviation, and ultimately those soldiers we all serve that operate on the ground. So, good morning. First, want to thank Quad A for this opportunity to provide this update on aircraft survivability equipment, on behalf of Major General Gaylor and ultimately the United States Army Aviation Center of Excellence. I will say it's an interesting portfolio for TICM AB. It's not just ASC, but it's aviation logistics, which spent the last, the 2 days previous here with regards to the Cribbins, and then we also do air traffic services. The uniform piece of it, kind of the integration piece. So I know some of you, some of the time will ask questions about those areas too. And then also the air traffic services piece. It's an honor to speak to this group of professionals and ultimately representing, not just the Army, not just the operational Army, but ultimately the acquisition corps that we rely so heavily on, but really also industry. And there's so many of the partners in industry are out there. And the one thing I will say we at least all have in common is wanting to field the most advanced aircraft survivability equipment to our Army aviators. It's definitely a team effort. I've learned that over these last 2 years. And I'll just mention some of those organizations. And it's really a cross-organization effort. I think some of the time we used to have bins of excellence. I think funding and some of the relationships to speed have now driven us to come together much better as a community. So when you have multiple PEOs, multiple PMs, across TRADOC, special operations, AMCOM, the S&T community, DAMO AV, FDV, all those pieces in the building, everybody working together and everybody messaging, we really can make things happen. And I think that's been proven over the last few years. And it's due to the hard work of a lot of people in this room, but also the environment. And I'll definitely talk about the threat a little bit here in a second. But it's allowed us to field those capabilities that our aviators deserve. As I stated earlier, and I think it's important because we all have to understand the environment. Just like we have to understand the threat on the battlefield, we've also got to understand our environment, whether it's with industry, in the building, or even just around the Army. And I think we all understand there's changes occurring. But it's no surprise to anyone here that funding is a challenge. But those efforts of all those people I just mentioned is the reason we've been able to make some of the changes that we've had. ASC is an enduring priority. It directly enables reach, protection, and lethality, and ensures our ability to conduct combined arms maneuver in both a challenging and an extremely complex environment. And there's no doubt in my mind that our partnership with industry is critical to understanding what is possible and the trades that exist between capability, timeline, and cost. And I kind of want to reiterate that. Industry really does help us figure that out. And I will admit, every time that I get to meet with industry, I walk away and I've learned something new. And it's a better understanding of a capability, it's a better way to possibly brief an opportunity that exists, or it's a better way to say how something we've done has impacted their ability to provide what we've asked them to provide. So I appreciate that interaction, and I think everyone understands just how important that is. So this morning, I'm going to briefly discuss the threat, mention some challenges associated with the development of aircraft survivability equipment, briefly discuss current and future ASC programs with regards to both detection and defeat, ASC Modernization, and then what we're doing to optimize our ability to fight tonight. So with regards to the threats, and as a person who served his entire time in the operational Army, really until my coming to record this assignment, the threat was always one of those most important things. If you ever did anything, you always made sure you did good mission analysis. So the point I want to make is that our threats are like each of you. They're intelligent, and they're driven to defeat those they perceive as enemies. Our peer and near-peer threats are leveraging advancements in technology to overcome what they have identified as our strengths since Desert Storm. And over the last 17 years, they've monitored how we've conducted operations, and they've created ways to mitigate those capabilities that we displayed. They've developed command and control capabilities to orchestrate the integration of multiple air defense systems and are utilizing passive threat detection technologies. They're exploiting the electromagnetic spectrum to challenge our capabilities and the way we use the electromagnetic spectrum. The speed of proliferation of advanced threats around the world also presents a significant concern. The mobility of some of the threats is also a challenge. And then threat weapon ranges also challenge our lethality and create a battlefield geometry problem that, if you'll go ahead and throw up the next slide for me, please, sir, that kind of lays it out. And I'll just take a second to kind of talk off of this slide. But this is one of the things that I think keeps us all grounded. When we really understand the battlefield geometry, and nobody needs to get excited, these are all unclassified distances and representations, but it's just a doctrinal template for us all to work off. But when we start talking about aircraft survivability, we have to understand the battlefield geometry, and we have to understand the relationships of how they're laid out on the battlefield. And I know everyone in this room understands it, but it's really it's another thing that brings us all together. So you can envision kind of this threat that's laid out. You could envision it somewhere in Eastern Europe. You could envision it somewhere in Korea, or even somewhere in China. But it would look something like this. And then I think the thing here, too, that this slide doesn't really depict is the altitude piece, too, right? It's everywhere from the ground all the way up to, thousands of feet. But it really lays out, hey, there is a complex problem here we have to solve with aircraft survivability equipment. I think it also points to, and it's really that second bullet, it requires a suite of capabilities to effectively survive and fight and win in this environment. And General Volmick already hit some of those capabilities, and then kind of throughout the brief, I'll hit on some of those also. I think it also points out, just when you look at that the lower piece of that slide, when it just depicts some of those possible ranges, just how important. And I do very much feel that if General Gaylor was here, he would mention how important long-range precision fires are to not just our Army, but to Army aviation. And I will tell you, as a young lieutenant, there was kind of two things all those old warrant officers and those officers that I always looked up to that said. And I was a 58 Delta guy. I will admit we didn't have a robust ASC suite at that point, but they'd always say, fly low, understand where we're maneuvering, and your radio is your best friend because that's how you can call back to artillery. And that's really one of the things that our Army is kind of gaining back with that CFT, is the ability to cause the enemy to have to react to our ability to utilize long-range precision fires. And I very much think the CG would mention that. So I will go ahead and move on to the next piece and just briefly hit some of those ASC challenges. They're directly related to the threat, but I do believe it's important that we mention in this venue, because some of you are the people that will help us solve some of these problems. So one, I've already mentioned proliferation, but that really impacts predictability. And then this next piece is key. When we don't know the predictability as well, our current process is actually pretty slow in responding. And I'd say it's more of a reactive process, right? And I think everyone in here understands, the process is threat exploitation and then kind of algorithm development. So that's a significant challenge I think we all understand exists, but how we're going to overcome that and how we're going to move towards a more proactive system to detect and defeat the threat. I think it's always, especially when you talk about Army aviation and aircraft, but just the space, weight, and power is always a factor. And then also, just the fact that, some of our platforms are definitely older. That was talked about a lot the last 2 days. But they're incredible platforms, and they're a modern fleet, and they'll be around for years to come. But I think with that, and how they were designed and when they were designed, there are some challenges to how fast we can integrate technology onto those platforms, whether it's hardware and software. And I think that's another one of those things that we have to overcome. And then just there's additional limitations. I think we're moving out and we're trying to solve them, but limitations associated with just modeling and simulations, what exists for us to, as fast as possible, create and develop those systems we need to keep pace with the enemy. But then there's also some limitations associated with testing and just the aircraft available to test and the availability of those testing facilities. So all challenges that everyone in this room is getting after and addressing. So then the next piece that I'll go ahead and hit is the next slide. And I won't spend a lot of time on this. General Volmick's already hit some. Kevin will hit also some, Colonel Cheney, as he comes up and talks. But when you look at it, there really is a lot of programs there. And that means that our Army is making a huge investment, in our soldiers and in Army aviation. And you can't not, but at the same time, there's trades there, right? And it kind of goes back to the piece earlier. There's some hard decisions that have to be made. And really, the slide even starts once again. There's the threat on the left-hand side there just to depict it, just always reminds us. And then, hey, what are we doing with regards to detection and defeat to get after those threats? I think you can see there when you look at CMOS and when you look at the JUONs and the increased capability it provided there, but on the capacity side, it was pretty low. Then you look at LMWAS and the fact that it's kind of a bridging strategy, not kind of, it is a bridging strategy to kind of our future detection system, but it increased the capability for our aviators and increased the capacity that existed there. And I very much want to give credit to PMASC and General Volmick because, a lot of people didn't know how things would work out a couple years ago when we started that initiative. But from flash to bang, in 3 years, there's going to be a product fielded to better protect our soldiers and a much greater capacity out there. And that's just impressive, and it shows the Army is reacting. It shows that just the funding side is reacting, and also that industry is reacting. And it's a good example. And there's other examples that I could point to. And then it kind of points to the RF piece down there when you think about the APR 39 and those older systems that we're all familiar with. And I will say, if one thing as I leave the stage, you also remember too, and General Volmick hit it. I think we've done a very good job of addressing the man-pad, the IR threat, and that's what we've dealt with for the last 15 years. And because of proliferation, I think we'll continue to deal with that, especially when you talk about more stability operations and low-intensity conflict. But on the RF side, there are some gains that we need to make and we have to make and kind of mitigate that gap. So on the RF piece, there's DV2, and then that'll kind of be a bridge to MRWR, that greater detection we demand. And then when you also think about on the RF side, it's not just the detection piece. You just don't want to know that someone is threatening you. You also want to know that you can defeat that threat. So kind of where we go over the next few years with electromagnetic or those countermeasure piece, and then also on the expendable piece. And I think that's something that sometimes we also forget, and that's one of the challenges I've given industry when I get to go out and talk and see people. When you think about flares and chaff, we've made some advancements with them, but I think there's even more opportunities there, and especially into the future, and especially on the RF side. So that's one of the things we're very interested in, and also too, with some of the challenges that exist, in the future, some of those future defeat systems, we may not have enough money to buy that defeat for every single aircraft. But those aircraft will kind of give us, possibly a tiered approach to the fleet. But on those aircraft that may not have the most advanced defeat system, having more advanced expendables is one way to provide them, greater protection depending on where they're operating on the battlefield. So just one way that we kind of see it and look at it is we've got to make those hard decisions in the future. And so then the next piece, I'll talk ASC modernization. And the one thing I'll say, and the one thing I always challenge my team with back at Fort Rucker, great football teams, and it is college football team, right, our time, so we can talk a little football. Those great teams, they don't focus on that last game they won. I would tell you a great team, even if they won the game, they focus on the mistakes they make, and then they're in there on Sunday morning, if it's a college team, or Monday, and they're looking at that team they're about to play next week. and they're thinking about what they have to do, what they have to change to beat that next week's, opponent. And that's really what we've got to do all the time. And due to technology and how fast it advances now, we don't have time to sit back and high-five about what we accomplished with a previous program or what's on our aircraft now. We've always got to be thinking about how we can, better modernize and advance our ASC suites to make, those best systems possible. So I think part of that is really one of those pursuits is open systems architecture. Open architecture should increase competition, reduce costs, shorten the time associated with development, and increase the ability to rapidly integrate software and hardware to retain overmatch as new threats emerge, or at least to keep pace with those threats. A universal AKIS should reduce weight and power requirements and the aircraft downtime associated with fielding new hardware. Advanced processing with the potential for growth as part of a universal AKIT can also facilitate the rapid integration of new technology and support home station training initiatives to host onboard training solutions with or without B kits. And I do want to mention, some of the time those B kits aren't available because that's the most expensive thing. So how do we provide our aviators the ability to train when they're home? Another key component of ASC modernization will be the development of the capability to transition away from our dependency on threat exploitation and specific algorithm development, creating a more proactive capability, focusing on the ability to characterize the threat and then cue that defeat capability. And I know that's the second time I've hit it, but I truly believe, and the branch believe, that that's where we have to go in the future, and how we create that, and everyone in this room has a role in figuring that out. There's also a piece of leverage in the network. It's 2018, and still when a particular suite of ASC identifies a threat on the battlefield, you either have to text it over a BFT or you've got to cue a mic. Well, as our Army brings on board a network where we can rapidly send voice and data transmissions, the ability to send that information, between aircraft, between flights, and to command posts will really increase our ability to make decisions faster in the enemy. So this suite of ASC equipment, it's got a direct link to that connectivity. And I think that will provide us another advantage. The piece that I'll say with that too is, it will be imperative in creating that ability to really be able to, and this is another thing that the CG always says, and one of the things that I think, it's one of those strong points that he makes, but really our ability to sense, see, identify, geolocate, share, target, and then destroy that threat. And that networking piece is critical to that. We must also create an ability to reduce our signature on the battlefield and really leverage that electromagnetic spectrum, to make us better. And really that's bringing both a low probability of detect and intercept capability, and something that we always have to think of when we're creating some of these systems, because there are second and third order effects with the way we design some of the systems, and it's always got to be there in the back of our heads. Also looking for opportunities to exploit multifunctional hardware and technology. The ability to combine those processes to drive down costs, and ultimately an example I'd give of that, and not to say that it'll happen with every single sensor, but I do believe there's some opportunities out there when you look at ASC sensors and then you think about DVE sensors, and the ability to use some of those sensors to provide kind of multiple functions, right? And then how the processing and all that'll work, that's key to figure out. But being able to only have one sensor that provides two functions is just critical in so many ways, and that's really something that we've got to look at hard. The piece I'll say with DVE, and I know it's still at the bottom of this slide here, so I'll hit it. Our initial efforts there were really about mitigating risk, but really where we're going with DVE is the ability to leverage our ability to operate in multiple degraded visual environments to bring on board an advantage over the enemy. And when you think about all those components involved with DVE, whether it's the flight controls, the symbology, or the sensors, that becomes a pretty expensive endeavor. But I will say this, when we're able to bring all three of those things together, and that sensor package, depending on how much it may or may not cost, when it creates a real operational advantage, I guarantee you that's when people will look at even more at, hey, this is something we've got to leverage on our platforms. And I think we're moving in that direction. We're just not quite there yet. The other thing I'll mention is just, and I think this is key, and especially for all the AMSOs in the room, there's no technological solution available today that we can provide the force that is more important than training our soldiers to plan and execute operations with what they have now. And I mean, that means the ASC that's on our aircraft now. I think some people will say 80 to 90% of defeating an IADS is just how well you plan to defeat that IADS. And I think, USACE very much understands that. So there's been advancements and changes made in the AMSO course. There continues to be updates there. And then also just one example I want to hit really quick, and I think some people in here are familiar with it, but even General Gaylor and USACE sponsored a quick reaction test that was actually executed back in the summer of 2017. But through that test, went and gathered subject matter experts from across the joint community, from across the Army, developed some tactics, techniques, and procedures and maneuvers, and then validated those out at China Lake. And then as a result of that, took those validated maneuvers, created training support packages that have been sent around the force to really help and to kind of give a product to help those cabs train and get after, operating in that environment. And then a follow-on to that, I'm happy to say we were awarded another QRT back in October, and so the plan is now to execute another QRT out at China Lake this coming summer, the summer of 2019. And that QRT will be a continuation of the one we executed, but we'll really get after now multi-ship tactics, which is actually how we'll deploy and fight, in a multi-threat environment too, where that first QRT, just to get the data and to get kind of that robust rigor into the testing that we needed to really get the statistical confidence to make sure we understood what was happening when we were maneuvering and expending those expendables, it really had to be, it was single ship against single threat. So a continuation of that. And that's all about making that investment in our force. And I think it's also key, even just the investment, PMASC and hosting the conference, ultimately with Quad A, these 2 days, but these 2 days prior where everybody's be able to get together and have those classified sessions. So all very important. So in closing, I'll just leave you with a few quick thoughts. Ultimately, that slide that I showed earlier, that battlefield geometry and that threat, that's what drives us every single day. I think a simple way to think of threshold requirements is really our ability to detect that threat prior to us entering the weapon engagement zone. I would say an objective requirement would be our ability to detect that threat before that threat can ever detect us. And that becomes a real challenge, and I'm admitting that's why it's an objective. But there's no reason with having a really good stretch goal. As mentioned, multifunctional sensors and payloads, and then also open systems architecture. And I think, how well we sustain what we have, how well we develop kind of our next suite of ASC, we all want to do that. And it's undoubtedly on all of us to make sure we do that, because those soldiers that are out there flying in the platforms, some of them here in this room today, and then ultimately those soldiers on the ground that expect, capability delivered by those platforms, that's what we owe them. And, to fight, to conduct operations, and it's kind of laid out with the multi-domain operations piece, it's complex. And it really, as I started, it is a team effort, it's a team sport, and every single person in this room will contribute to making sure we do provide the best that we can for our soldiers. So I will end there and then open up to any questions. We'll see how, if they're really hard, I may have to get Colonel Cheney to answer them.
Hi, Chris Austin. When we look at ASC, right, we talk a lot about legacy fleets. How is that ASC being looked at similarly or differently for future verticalist aircraft?
So it's a good question. Future Vertical Lift is looking at what we're doing right now. I would tell you the next 2 days I will be spending time with them just talking about the programs. But there are conscious decisions being made on what can we field now that continues to advance this modern fleet that we have, but then what are programs that may or may not be fielded on FARA, and then may, kind of backwards compatibility to our current fleet. But that's all being looked at really hard. And like, Chris, those trades that I talked about, industry helping us figure out, hey, what can we produce now that we could put on that FARA aircraft? But at the same time, I think everybody in this room understands we can't have such stretch goals or kind of we don't want to make that aircraft so expensive with what we think we can put on it that it destroys the effort either, right? So, those are all the discussions and decisions that are being made right now. I don't know. There's not, you can look at each individual program and kind of see, hey, what may go on FARA? What is something we're developing that'll go on FARA, and then have backwards compatibility?
Anyone else?
I appreciate it. There's no hard questions there.
We're waiting.
Hey, Ryan, thanks for a great update. And while you may believe that General Gaylor can't be replaced, you did a great job, and I'll let him know that you can do it again next year if he's okay.